Hi, welcome to Mutually Exclusive or Not video. In this video, your learning goals are you need to learn to distinguish a mutually exclusive and a not mutually exclusive event. The second one is to learn to solve mutually and not mutually exclusive events, probabilities. Okay? So let's talk about mutually exclusive event first. Okay, so given a problem that says there are 3 red, 4 black, and 5 blue cubes in a bag, and the question is, what is the probability of selecting a red or a blue cube? Okay, you have done this before, but you are not just aware that you are doing a mutually exclusive event probability. Okay, so let's go, and then probably inside your head you already know it's 8 out of 12. So, but let's talk about it in details. Okay, first thing that you will do is that you're going to count all the cubes inside the bag, and you will know that there are 12 in total. And then, so that's the total number of possible outcomes. And then you look at red, and there are 3 reds, and then you count the blue, and you will count that there are 5 blues. So 3 plus 5 is 8, so 8 out of 12. So what you actually did was, here's the proper math notation: P, red or blue, probability of red plus probability of blue, and you will end up with 8 out of 12. Now, I want you to take a look at this. You are now using OR. We did AND law, and so here in mutually exclusive, you are using OR. Okay? So another one is you're given a deck of cards, and what's the probability of finding an ace or a king? So here are the cards. Okay, I'm going to show you, it's 8 out of 52. So you count the number of aces, 1, 2, 3, 4. So that's 4 out of 52, plus for the probability of the king, there are 1, 2, 3, 4 kings. So 4 plus 4 is 8. And the same total number of outcomes, 8 out of 52. Okay? So then, for mutually exclusive event, you can tell it's a mutually exclusive event when the events that occurred could not have happened at the same time. The ace is not going to be a king, or king. You won't have a card that is both king and ace. It will just be a king, or it will just be an ace. On the other hand, for the cube, it can only be just blue or just red. There's no blue, red, or black, blue. Okay? So that's what you call mutually exclusive. So then, events that cannot happen at the same time are called mutually exclusive. And remember that you add the probabilities. With the AND law, you multiply the probabilities. Okay? So for the OR law, you go probability A or B is equal to the probability of A plus the probability of B. Okay, so here's a number line from 0 being impossible to certain. If we are using OR law and we are talking about the probability of red, if I put 3 out of 12 in this number line, the red is over here. Okay? Now, if we add OR, so it's going to be P, red or blue, so you add the probability of blue, you will end up with 8 out of 12. So in the number line, okay, it has reached more than a half, more than 50%. Okay, so in OR law, when you're saying OR, your probabilities are the probabilities becoming higher and almost going to 1. So if I add one more event, so if it's probability of red or blue or black, that means all the colors of cubes inside the bag, you'll end up with having 1, which is 100% or for certain. you will definitely get that cube. Okay, so then the difference between or and and is that when you're using and law, your probability, because you're multiplying, so then your probability is becoming smaller and smaller. With the or law, because you are adding, you are going near 100% as you add another event. Okay, so I hope that was clear, the difference between and law and or law. So now let's talk about what is not mutually exclusive. Okay, given a deck of cards, so you have 52, your or law is what is the probability of selecting a diamond or a queen. So if you take a look at the deck of cards, the third row are your diamonds, okay? And then the queen is over here. As you can see, there is one card that share both qualities or quantity. This card is both queen and diamond. Okay, so this is what you call not mutually exclusive. Okay, so if you try to use the OR law, then what you will do is probability of diamond plus the probability of queen. So you're going to count the number of diamonds in the deck of cards. You will have 13 out of 52. And then you'll count the number of queens and you say there are 4 queens here, so plus 4 out of 52, then your probability is 17 out of 52. In a not mutually exclusive event, this is not the case. You will count this queen, which is also a diamond, as 1. So the probability for this not mutually exclusive event is this. You will actually just have 16 cards and not 17 cards because this card is both queen and a diamond. So the probability should have been just 16 out of 52. Now remember, for the notation, you write it as if it's like a mutually exclusive event. You are still using or, but the procedure to get the probability is not the same. Okay, for mutually exclusive, you simply add all the events. Okay, how about this one, a spinner? Okay, what is the probability of the pointer indicating a green color or a number 5? Okay, so if, as you can see, this 5 here is also green at the same time. So this is not mutually exclusive because you have one that share both events or share both qualities or characteristics. So if you are trying to solve this using OR law or mutually exclusive, what you will do is get the probability of green, then add the probability of 5, and that will be, there's one green, so 1 out of 6, plus the probability of 5, there are 2 5s, so what you will do is plus 2 out of 6, which is 3 out of 6 or 50%. But that is not the case. It's wrong. For not mutually exclusive, you don't do that. What you actually, the probability is actually just 2 out of 6 because this should be just counted as 1, being green and 5. So you have 1 and then this one 2, so it should be 2 out of 6. Okay, I hope it's clear. Okay, now let's have 2 players and we're looking at player number 1. Okay, player number 1 lays a card at random from his hand. What are the probabilities of the card being a king or a 7, a heart or a club, a heart or a king? So what you're going to do now is stop the video and answer the question first. Once you have tried answering it, then play the video again and check if your answers are correct. Now, when you are doing that, I would like you to think inside your head whether the events are mutually exclusive or not. Okay, let's check your answer. For letter A king or a 7, 2 out of 7 plus 1 out of 7. Your answer should be 3 out of 7. I also would like you to check the notation. It should be written this way. Okay, so A is a mutually exclusive event. Letter B. Okay, remember that you are just looking at player 1. It didn't say player 2, so you're just looking at this. P, heart, probability of heart or club. So it should be 3 out of 7 plus 2 out of 7. Your answer should be 5 out of 7. It's mutually exclusive. Okay. Letter C, on the other hand, for a heart or king, it's a not mutually exclusive event. So then it should be 4 out of 7. It says heart or a king. So this card is both heart and king. Yeah, so and you only count it as one. Okay, so to summarize, for example, aces and kings, they're mutually exclusive, so they can't be both. And it can be seen in this Venn diagram. They're separated. They have nothing in common. On the other hand, if it's not mutually exclusive, for hearts and kings, they have something in common. That means you have one card that is both a king and a heart. And so that's not mutually exclusive. In general, the formula for mutually exclusive is probability of A plus probability of B. As for not mutually exclusive, please write this down in your notebook. P, the same notation as mutually exclusive, probability A or B is equal to the probability of A plus the probability of B minus probability of A and B. Now remember, when you are using AND, you are with AND law, and so you are multiplying. So you subtract the product of the probabilities of A and B, and you should get the answer for not mutually exclusive probability. Okay, why don't you try that in the other problems that you have done already? If you would really get the same, if you do probabilities of A, probability of A plus probability of B minus the probability of A and B. Okay. Now, here are some few questions that I would like you to answer. Which of the following pairs of events is mutually exclusive? Choose one, A, B, C, or D. If you need to pause the video, please do so you have time to understand the problem. Once you have the answer, you can play the video again and check if your answer is correct. Let's check your answer. Your answer should be sit down and stand up. That's your mutually exclusive event here. Okay, let's move on to the next question. A card is chosen at random from a pack of 52 playing cards. What is the probability of a king or a queen? What about this probability? Is this a mutually exclusive or not mutually exclusive? This is not mutually exclusive. So let's see what the answer is. I hope you already have an answer. The correct answer is 1 out of 13. Now, the answer here is the simplest form. In your notebook, if you have written something, maybe you did not express this in simplest form. That's why you have the wrong answer. So make sure that it's in the simplest form. For the last question that I would like you to try, a number is chosen at random from the set of 2-digit numbers from 10 to 99 inclusive. What is the probability of a number? The number contains at least one digit 2. So I'd like you to think carefully. Okay? The correct answer is 1/5. And here are the considerations that you need to count. Here are the ones that has 2 in the 2-digit number. You have 1222 until 92, and then 2021 until 29. And 22, this is a not mutually exclusive. We should count 22 as 1. Yeah? And then remember 1/5 because it's expressed in simplest term. Once you are done with this video and you have a good understanding of this video, of this topic, you may now move on to independent practice. Okay. Bye, grade 10.